Hello, everyone. So, today we're going to be looking at some problems involving line segments and finding the values of the lengths of segments and all that fun stuff. So, let's start with this problem. I'm just going to preemptively draw a line segment. Alright. M is the midpoint of the segment AB, and N is the midpoint of the segment BM. If BN is equal to 4, then what is the measure of AB? So, read the problem out and you can deduce the order of the points based on which midpoint is located where. So we have M is the midpoint of AB. Okay, so we know wherever M is, it's halfway between A and B. Then we have that N is the midpoint of BM. So N is going to be, again, halfway between B and M. Now, because M is a part of the segment BM, that means that we can infer the two endpoints of this segment are going to be A and B. Because we know that M is going to be at the midpoint, so somewhere over here. And that N will be placed between the segment BM, which is the segment right here. So the point N must go halfway between those two. And this way everything makes sense. M is halfway between A and B, and N is halfway between B and M. So how can we work out the solution from here? Well, it tells us BN has a value of 4. Okay, so I know that this distance is 4. Well, how can I find AB? Well, we know that since N is the midpoint, that NB and MN have the same values, because N is precisely right in the middle of this segment. So MN must also have a value of 4, which means that MB has a total length of 8. Now, we also know that M is located in the middle of AB. So what that means is that MB will have the same value as AM. So AM will also have a length of 8, meaning that the length of AB in total is 8 plus 8, which is just 16. So you're just using facts about midpoints and the fact that a midpoint splits a segment into two equivalent pieces. So with that being done, let's check out another problem. All right, so again, I'll draw a segment preemptively, and let's read the problem. So P, Q, R, S, and T are on line K such that Q is the midpoint of the segment PT. R is the midpoint of the segment QT, and S is the midpoint of the segment RT. If PS is equal to 9, then what is PT? So again, look at the order of things. All right, Q is in the middle of PT, R is in the middle of QT. So that means R will be sort of like in the inner part of the segment, just like how point N was over here. So we can just go ahead and say that the two endpoints are going to be probably P and T. So again, Q is the midpoint of PT. So somewhere in the middle is point Q. And then R is the midpoint of QT. So somewhere in the middle of QT is the point R. And S is the midpoint of RT. So halfway between R and T is the point S. So here's the segment that we're working with. We know that PS, that length is 9. So this entire segment right there, 9. Okay, well, we want to find the length of PT. We're given PS and a bunch of midpoints. So what can we reasonably do? Well, the missing part that we would need to find PT is ST. I want to know what this value is. Because if I know what that value is, then I can just simply add it with 9 and get the total value for PT. So algebraically, I can create an equation like this. PT is equal to PS plus ST. And then, of course, we know that PS has a value of 9, so I'll just substitute that in. So PT is equal to 9 plus ST. All right. Well, I don't know what ST is, so we hit a dead end for now. So what can we do from here? Well, let's figure out what we know about ST. So ST, we know S is the midpoint of RT. That's something gave us. So what that means is S is going to split the segment RT into 2 equal pieces, like this. But what this also means is that ST has a value of 1/2 of RT, because again, the midpoint splits it in half. So ST is equal to 1/2 of RT. Okay, that's fine, but where else can I go with this? So I don't know what the value of RT is, but I do know that R is the midpoint of QT. So I can express RT in terms of QT, just like how I expressed ST in terms of RT. So RT, because R is the midpoint of QT, that means RT is half of the measure of QT. 1/2 QT. And, alright, I don't know much about QT, but I do know that Q is the midpoint of PT. Therefore, QT, with a similar kind of logic, we can figure out QT is 1/2 of PT. And now we can sort of just substitute in all these equations we have into the equation with ST that we started with over here. So ST is 1/2 RT, but RT is 1/2 QT. And we can go further because QT is 1/2 of PT. And 1/2 times 1/2 is 1/4. Times 1/2 again is 1/8. So ST is equal to 1/8 of PT. Okay, that's something that's useful. Why? Because now I can replace ST in the equation over here with 1/8 PT. So let's go give ourselves a little bit more room. So PT is equal to 9 plus, again, replace ST with 1/8 PT. And now we have an equation with like one unknown, and since we only have one unknown, you can think of it almost like a variable. We can solve for PT. So to isolate PT, I'm going to subtract 1/8 PT on both sides. of our equation. So PT minus 1/8 PT, well, this PT, we can think of it as 1 PT, 1 times PT. So that way, all you're doing is 1 minus 1/8, which is 7/8. So we have 7/8 PT, and that's going to be equal to 9. All right, then to get rid of the 7/8, you can multiply by the reciprocal or divide both sides by 7/8. I'm going to just multiply by the reciprocal. So I'm going to multiply both sides by 8 over 7. That way, these values will cancel out, and we're simply left with the fact that PT is equal to 9 times 8/7. Well, 9 times 8 is 72, so that's 72 over 7. And that is our result. So there are a couple examples of some problems involving the lengths of segments. As you can see, the idea of using the midpoints is very, very helpful to set up some equations to help us solve the problem.